Part 1. So ionic compounds. Part 1. Now, I think the question would be, and the thing we need to focus on first off would be recognizing how we know if we have an ionic compound. And one of the things we can see is that ionic compounds have the potential to contain nonmetals. So ionic compounds probably contain metals. They probably contain metals in them. That's not all they have. Very often, they have the potential, so they may contain polyatomic ions. If you remember, you copied those down about a week or so ago. Do you remember copying those down?
Yeah.
There's like a listing of about 15 of them, and you've got to know them. They may also contain transition metals. Now today our focus is going to be on everything but talking and using our polyatomic ions. So we'll work on naming ionic compounds for about another day or two, but today I'm going to talk really about having metals, transition metals with only nonmetals, and no polyatomic ions. Okay? So today, in other words, my focus is going to be on the simple ionic compounds. That's why we've got at least 2 parts worth of stuff. So we're going to work on naming the simpler ionic compounds, what I would call the binary ionic compounds. Binary ionic compounds contain only 2 things. They contain positively charged metals. So they contain positive metals. We call the positively charged particles cations. And negatively charged nonmetals, which we call anions. One thing we also have to remember to do is that we are required to crisscross our charges to make subscripts. Subscripts are, of course, the little numbers. Subscripts are the little numbers. And the nonmetal always ends with an IDE ending. We saw that trend when we were talking about nonmetals 2 days ago. And then lastly, the charge of transition metals is indicated by a Roman numeral in parentheses. So let me show you with some examples on how we're going to work on naming these things or writing the formulas of these things. So you can copy down several examples. Copy those down real quick, and we'll talk about them. How would we know these are all ionic? They all have metal in them. Once we see that metal, we know for sure we've got ionic compounds. And of course, we don't see any prefixes either. So for sure we have ionic compounds. Now, as I said before, we have to crisscross our charges. So when you're done writing these down, maybe one thing that you might want to do, and it depends on your strategy, but why don't you go looking for all the charges of these guys real quick. So again, go looking for the charges of all of these guys. And your periodic table would assist you in this endeavor. Table. So sodium is what charge? +1. Aluminum is +3. Magnesium is +2. And strontium is +2. I think we all got that correct. Chloride is 1-, oxide 2-, oxide again is 2-, and fluoride is 1-. You're all seeing where I got this from, correct? Okay. So my next step with this stuff is going to be to write out these charges right next to my elements, and let me show you how I do that. I write Na, that's sodium, and I write 1+, and chloride Cl, which is 1-. And my next step is to crisscross those charges, bring them down so that the 1 is now here and the Cl is now here. Now in math, you know how when you solve the question and you get to the very end and you write x equals 12, do you ever write the answer 1x is equal to 12? Or do you write x equals 12? You never write the 1 because it's understood, right? We're not going to write these 1s because they're understood. Notice we're not bringing down the positive and negative sign, we're just bringing down the number. There would be 1 after the Cl and 1 after the Na. Since they're both 1, we could ignore them, so it's NaCl. Good? How about aluminum oxide? Aluminum is Al, and what's its charge? 3+. And how about oxide? It's O with a 2-. Am I going to bring down my positive and negative signs? No. Just the number. Bring down my 3 to after the O, and my 2 to after the Al. Do you see it's called crisscross? Because you're bringing the numbers down. That's Al2, O3. The next one, magnesium oxide. Magnesium is Mg and it's 2+. O is 2-. Now you would suspect that I'm going to bring down the 2 to the O and the 2 to the Mg, but here's the deal. If they're the same number, or if you could reduce them, you're allowed to. Like in math, if you get 2/4, a lot of times your teacher would count that wrong because what is 2/4 equal to? 1/2. Or if you got 2/2, that's really saying 1/1, which is equal to 1, right? Since these are the same number, you could reduce them down by a factor of 2, leaving you with MgO. Because they're the same number. The signs they never ever come down. So you will not bring down the signs. Strontium fluoride. Strontium is Sr and it's 2+. Fluoride is F and it's 1-. Bring down your 2 and your 1. That leaves you with Sr, F2. Did I bring down my signs at all? No, you never do. Why don't you work on a couple with someone around you? Spend a couple seconds working on these. I'll give you some examples. Aluminum nitride, calcium sulfide, magnesium, nitride, iron 3 oxide, cobalt 2 sulfide, let's see, potassium nitride. So write those down real quick and then work on getting those formulas written, and then we'll discuss it.